Okay, in this demo we're going to look at chi-squared tests and in particular chi-squared goodness of fit test in this particular demo. Okay, so let's load in the data. I'm going to import data from text file, comma separated as usual. This is the EELS data from lectures, so I'm just going to change the name to EELS. Okay, open it. View the data set. We can see what we have are a bunch of eel IDs, the locations that these eels were sighted, the species for each eel, and a length variable there. So this is in what we call raw data format. We're not particularly interested in the length of the eels here. We really want to know, as in lectures, is the spread of sightings across different locations, does it correspond to certain distributions or not? And in lectures we looked at two distributions. We looked at an even distribution and we looked at a 50, 30, 20 type distribution across the different levels. Okay, so let's do this one. To do the chi-squared test we look at summaries, and we go to this tab here where it says frequency distributions. We click on that. Which variable are we using the frequency distribution for? Well, in this case it's location. Now I want to do the chi-squared goodness of fit test, so I'm going to tick chi-squared goodness of fit test there. I'm only selecting one variable. Okay, so the goodness of fit only applies to one variable. If I click OK, it then says what are the hypothesized probabilities of being in each of those levels, and they're defaulting to 1/3, 1/3, 1/3, which is the default that I want for the initial test. So now we click OK, and down here at the bottom you can see we get a chi-squared statistic of 127.259, 2 degrees of freedom, and a tiny p-value less than 2.2 times 10 to the minus 16. So it's highly significant that they're not evenly spread across those three locations, that the eel sightings are not equally spread across those sightings. We can go back to that table under summaries, frequency distributions, still location, still chi-square goodness of fit, apply, and now we can change these to the other proportions we used in lectures, which were 50% for border, okay, or 0.50, 30% for grass, and 20% for sand. If we click OK now, we find we get a chi-squared statistic of 0.3645, again on 2 degrees of freedom, and a p-value of 0.8334. So that is not significant. Okay, so there is no significant difference or evidence of it being different from that second distribution of probabilities. Okay, now there's one other situation in which we might want to test things, and that's where we don't have the raw data. Suppose we only originally have the summarized data. Unfortunately, there's no dialog for a chi-squared goodness of fit in R Commander when we have the summarized data. Okay, but we can easily do that manually. Okay, what we do is we click on this R script window at the top, okay, and we type in chisq.tst, open brackets, C, open brackets, and then we type in the numbers we want to test for. And remember that the summary numbers were 425 for border, 243 for grass, and 166 for sand. We need to close those two brackets, and then we click on submit over here, and you see we get the same chi-squared statistic, the same degrees of freedom, and the same p-value as before. That's by default tested against the even probabilities. If I go back, I can actually edit that line and say that I want to try probabilities corresponding to different to the other case. We do C 0.50, comma 0.30, comma 0.20. Again, close brackets there, so we've got even. I've got p equals for the probabilities there. I've got the original data there. If I submit that one, you see we get identical results to using the raw data. Okay, with the chi-squared statistic. Okay, so that's chi-square goodness of fit. That's the end.